It's one of the most consumed meat products in the world. Known for its jelly-like texture and uniform taste, luncheon meat dominates breakfast tables, from school meals to luxury hotels. It started as a way to preserve leftover meat, but it turned into a precise craft based on food chemistry. Luncheon meat isn't just ground meat, it's a complex emulsion that brings oil and water together inside a protein network. But how do they produce tons of it every day with the same consistent quality? The journey starts in a tightly controlled environment where bacteria are the #1 enemy. Today, we'll zoom in to the microscopic level to see how fibers break down and get rebuilt. The secret is speed, cold, and high pressure. Behind every slice of luncheon meat is a kind of math that keeps flavor and texture in balance. So let's go back to square one, where the story begins with a frozen block. The raw materials arrive as pure frozen beef blocks at -18 degrees Celsius, about 0 degrees Fahrenheit. Keeping that temperature is vital to prevent microbial growth and to make the first grinding step easier. Next, the packaging is removed in a clean area to prevent any physical contamination. At the same time, solid animal fat is prepared, the ingredient responsible for tenderness and a creamy texture. Starch also plays a key role by absorbing water and binding ingredients together, along with a secret spice blend that often includes white pepper and nutmeg to boost flavor without changing the color. Then there's sodium nitrite, the chemical that gives the distinctive pink color and protects against botulism bacteria. Meanwhile, crushed ice shows up not just for cooling, but as a core part of the equation, added as water in solid form. Before anything starts, a meat sample is tested for fat and protein to set the standards. The meat must be completely free of biological contaminants before it enters the production line, while the equipment waits clean and sanitized, ready to receive tons of raw materials. Once everything is ready, meat, fat, ice, and spices, the physical journey begins. The solid meat blocks are lifted toward the crushing machine. The first stop is the giant crusher, known as the flaker. It's designed to cut frozen meat without thawing it, keeping the juices inside. Steel claws break the solid block into thin slices that look like wood shavings. The result is frozen meat flakes, which makes fine grinding easier later. Then, the meat is weighed with extreme precision. Any mistake in the ratio can make the emulsion fail. The meat-to-fat ratio is set often 70% meat, 20% fat, and the rest additives. Now the ingredients move to the first grinding stage to standardize particle size. A spiral screw forces the meat with huge pressure toward rotating blades, grinding it through 5mm holes and turning it into long strands. This breaks down large muscle fibers and prepares for protein extraction, while a smart mechanical system separates any hard bone remnants that might have slipped through preparation. Adding salt at this stage isn't just for taste. It kicks off a key chemical process. Salt helps break down myosin protein, the natural glue that will bind the luncheon meat. Then, the mixture rests briefly, allowing partial protein breakdown. Next, we reach the heart of the factory, the cutter, the bowl chopper, the machine that turns rough meat into a smooth, uniform paste. The blades start chopping the mixture and initially blend the meat with the fat. At that moment, ice is added immediately because friction generates high heat, and the ice is necessary to prevent the protein from cooking too early. As the ice melts, the water becomes part of the emulsion, mixing with the protein and fat. Then, phosphates are added to increase the meat's ability to hold water, ensuring the final product stays tender. The blades speed up to extremely high speeds, tearing fat cells apart. Physically, protein coats the microscopic fat droplets and prevents them from merging again. Spices and starch are spread evenly to ensure flavor reaches every millimeter. And to enhance the color and make it appealing to consumers, safe natural colorings are added. The mixture temperature is kept under 12 degrees Celsius, about 54 degrees Fahrenheit, throughout mixing. After that, a vacuum system is activated to pull out any air bubbles. Removing air prevents oxidation and makes the texture dense and fully cohesive. Then the blades stop. What we see now isn't ground meat, but a meat emulsion. The texture should be sticky and very smooth, like heavy dough. The mixture is immediately pumped to the filling stage before its temperature rises. Tubular casings are prepared, usually made of cellulose or heat-resistant plastic. Under high pressure, the paste is forced into the casings, so there are no voids. Next, an automatic clipping machine seals both ends of each luncheon meat log with a tight aluminum clip. The logs come out identical in shape and weight, ready for cooking. They're arranged manually or automatically on racks that let steam pass between them. Then the carts are pushed into massive steam cooking ovens, starting pasteurization and cooking. The temperature rises gradually and precisely. It's not raised suddenly, but in stages, so the protein sets slowly. Steam is used because it transfers heat well and keeps the casing moist. A smart probe monitors the product's core temperature, with the goal of reaching 72 degrees Celsius, about 162 degrees Fahrenheit, at the center enough to kill bacteria. The process continues for several hours, depending on the log diameter. During this time, starch and protein turn into a firm gel, the gelation process. Once the target time and temperature are reached, the ovens stop. The carts come out extremely hot, but the risk isn't over yet. The product must be cooled immediately to pass through the bacterial danger zone quickly. Thermal shock stops cooking and locks in the final texture. After water cooling, it moves to air chillers to bring the temperature down to 4 degrees Celsius, about 39 degrees Fahrenheit. Then the luncheon meat rests for 24 hours, so flavors blend and the texture stabilizes. The next morning, a new chapter begins. Final processing. If the product will be sold sliced, a specialized machine cuts and removes the casing automatically, revealing the polished surface firm and bubble-free. Then an ultra-fast slicer grabs it, with a blade spinning hundreds of times per minute, turning the log into hundreds of identical slices. The slices stack with geometric precision into groups of a set weight. Any group that doesn't match the required weight is immediately rejected by an air blast mechanism. Then the groups move to a thermoforming packaging machine, where the tray bottom is formed from a rigid plastic roll using heat. After the slices settle precisely in place, the top film comes down to seal it. Before the final seal, oxygen is removed and nitrogen gas is injected to keep it fresh. Then the edges are heat sealed, making the product isolated from the outside world. After that, the connected packs are cut into individual retail units. Then comes a critical stage. Every pack passes through a magnetic field to detect any rare metal fragment. If the device detects anything abnormal, the pack is forcefully ejected immediately. Then the production date is laser etched, no room for tampering, while smart vision systems confirm the package shape is intact and the printed data is clear. In parallel, the lab runs taste and texture tests. A special device presses on a slice to measure elasticity and resistance to cutting. Chemical checks confirm preservative levels stay within safe legal limits, and samples are placed in warm incubators for days to ensure no bacteria grow. After passing inspection, the packs head to final boxing. Robotic arms stack the packs into cardboard boxes at an incredible speed. The boxes are sealed and labeled with a logistics tracking barcode, then stacked on wooden pallets in an interlocking pattern for stability. The whole pallet is wrapped in stretch plastic to protect it during transport, and the goods move straight into refrigerated trucks because the cold chain can't be broken. Then the doors close, and the distribution trip to the market begins, with the product stored in huge warehouses before reaching stores. Finally, the product arrives in the display fridge, where the consumer sees it a long, complex journey reduced to this small pack. What looks simple is actually a win for food engineering. From freezing, to emulsifying, to pasteurizing, to smart packaging, all that work ensures a safe, tasty, affordable meal for millions, while the machines keep turning to produce thousands of tons to meet rising demand. And at the end of every day, a strict cleaning cycle begins, getting ready for a new day. That was the story of how luncheon meat is made like you've never seen it before.